Alright, in this video I want to show you how to solve what are called linear inequalities. And what's nice about this is it's almost the same thing as a linear equation. Really the only difference between an equation and an inequality is that an inequality has, instead of having an equal sign, it has a sign like this. It has a greater than sign or less than sign or less than equal to or greater than equal to. But otherwise the rules are the exact same. There is just one catch, you might want to call it, and that's kind of put in bright red here. It says if you multiply or divide by a negative number, you have to change the direction of the inequality sign. I'll show you why. Let's suppose that I had the following inequality. I said 3 is greater than 2. By the way that a lot of people remember this is the greater than sign. I don't know if you've ever played that arcade game Pac-Man. They always say the Pac-Man eats the bigger number. So you can see this thing is kind of opening towards the 3 instead of towards a 2, because 3 is the bigger number. So 3 is greater than 2. So here's a question. What would happen if I'm going to follow this rule of whatever I do to one side, I do the same to the other. So let's say I multiply both sides by 10. I would get 30 is greater than 20, and that's still true. I didn't change the inequality in that way, but this is telling us the following. Up here it's telling us if we multiply, should say multiply, spelling was not my best subject, as you could probably tell. If you multiply or divide by a negative number, so let's do the same problem, but now let's multiply by negative 10 instead. So this now is negative 30 greater than negative 20. Let me rewrite that. And that's not true. Negative 30 is not greater than negative 20. It's more negative. So we have to, in this case, in order to get it right, we have to flip the direction of the sign to get something true. So let's keep that in mind as we solve these problems. And I encourage you to try to pause and see if you can do any of these, because they're all based on properties that we've talked about before. So if you look at numbers 1 and 2, for example, you see those things in front of the parentheses. That probably means that we're going to have to use the distributive property. Okay, so give that a try if you haven't, and then we'll look at these answers. So I'm going to take the 8 and distribute, and we'll have negative 48n. That's 8 times negative 6n. And then 8 times 8 is 64. Greater than or equal to 112. We'll subtract 64 from both sides, and we'll get negative 48n is greater than or equal to, and then 112 minus 64 equals 48. And now in order to solve this, we see what's being done to n and do the opposite. N is being multiplied by negative 48, so the opposite of multiplying would be dividing. And then notice that we just divided by a negative number. So our final answer, these will cancel. We'll have n. 48 divided by negative 48 is negative 1. But notice the sign is opening towards the n, but now I have to flip it because I divided. So there's our answer. You can always check your answer, by the way. Suppose you had not flipped it. Suppose you did n greater than or equal to negative 1. Just take a number that's greater than negative 1. So let's take 0. If you plug 0 in right here, you'd have 6. Negative 6 times 0 is 0. 0 plus 8 is 8. So you'd have this. You'd have 8 times 8. That's coming from plugging in 0 up here. 8 times 8, which is 64. And the question is that greater than or equal to 112? And the answer is no, it's not. Okay. On the other hand, if you plug in any number in that range right there, less than negative 1, you will get something true. So you can see underneath each of these equations, our second task is not only to solve these, but also to graph them, because that's a common thing to do when you're solving inequalities. So here's how you would graph it. First of all, I'm going to put a dot at negative 1, because that's the number that we ended up with. And you should always decide whether you're going to shade or not shade that in. And the way that you decide is based on this. This is less than or equal to. So if you could be equal to negative 1, which in this case we could be, because it's telling us right here less than or equal to. If you could be equal to it, you shade it in. If it's only less than or only greater than, you would not shade it in. Okay, and then less than negative 1, you shade to the left, because these numbers to the left, negative 2, negative 3, negative 4, those are all numbers that are less than negative 1. So that's where we would shade. Alright, let's try number 2. So number 2, we have variables on both sides this time. So what we need to do after distributing is we need to get all the variables on one side and all the numbers on the other. And you can see in this problem that we just solved right here, variable on one side, number on the other. So that's the ultimate goal. Alright, so let's distribute the 7 and we'll distribute the 6. So 7 times 4 is 28. 7 times 5n is 35n. Less than or equal to 6 times 7, 42. 6 times 6n, 36n. And we have minus 6. So let's start moving things around. Let's move all the n's to the other side. We'll subtract the 35n. And then let's move the number. So 42 minus 6, that just equals 36. So we'll get rid of that. So we have a positive 36 right there, but I want to move that. So we'll subtract the 36, and then we'll subtract it over here as well. Whatever we do to one side, we have to do to the other. So those cancel. So 28 minus 36 is negative 8. We did not multiply or divide by a negative number yet, so we don't have to change that. It's not subtracting that makes it change, it's multiplying or dividing. And then 36n minus 35n is just 1n. So there we have n greater than or equal to negative 8. So try to ask yourself, when I put this point at negative 8, should I shade that in or not shade that in? And once again, the answer is we would shade it in because it's not only greater than, it's also could be equal to. Okay, and then what numbers are greater than or equal to negative 8? In the direction that I'm shading right now, to the right. Alright, number 3 and 4, these are called compound inequalities. These are a little bit harder. Compound means combination, it means multiple inequalities. So we'll start with number 3. Number 3 is called an OR statement, and it's called an OR statement because they're telling us that either of these two things are true. So let me just rewrite these right here. So basically what you have to do with an OR statement is solve them each separately, solve them each individually, which is what we're going to do right here. And we do them the same as we did before. So let's start with the left one. We want to move all the b's to one side. So I'll do that by adding the 8b, and we'll move the numbers to the other side. So we'll subtract the 5. So 1 minus 5 is negative 4, and then negative 4b plus 8b would be 4b. Our final step is see what's being done to b and do the opposite. It's being multiplied by 4, so we'll divide by 4. Negative. Now here's the one thing I want to mention. You might say, do I have to flip the sign? Because this is a negative number right here, and the answer is no, because we are not dividing by a negative number. We are dividing something that has a negative, but notice the number that we introduced is a positive number. It's only based on what we're doing. We're dividing by 4. We're not dividing by this negative. That negative was there to begin with. So in this case, we do not have to flip the sign. Negative 4 divided by 4 is negative 1, so there's our first answer, but we're going to hold off on graphing anything until we get the second one. So let's do the second one, the other side. So we'll move, once again, the b's to one side, and we'll move that number 1 to the other side. So we get 3b minus 2b, which is b, greater than or equal to 10 plus 1 is 11. So remember, this is an OR statement, and I'll show you why it's called an OR statement. So let's graph the b is greater than or equal to 11. Here's 11. Hopefully it makes sense to you why I'm shading that in, because it tells us right here not only is it greater than, but it could be equal to. And then numbers that are greater than 11 are in that direction I just shaded. Then we'll do this one. This should also be shaded in at negative 1, because it could be less than or equal to negative 1. And then what numbers are less than? Numbers to the left where I'm shading. So I told you I would tell you why this is called an OR statement, and here's why. You can probably tell from looking. Question I have for you is, could you have a number that's in both the red zone and the blue zone at the same time? And the answer is no. You can't have numbers in two different places at once. The reason it's called an OR statement is because numbers that satisfy it, numbers that make it true, are in either this region or they're in this region, but not both at the same time. Okay, number 4, the other alternative to an OR statement is like what we're going to do in number 4, and that's called an AND statement. Okay, an AND statement looks like this. You have a variable in the middle, and the variable is less than something, and it's greater than something else. So it's both greater than one thing and less than the other thing. So here's how we do it. We need to get the variable in the middle to just be a single thing. Like we're used to solving. Right here we solve for 1b, and up above we solve for 1n. So in this case we're going to want a 1a in the middle. And this looks a little confusing because there's 3 parts of this equation, but it's really not so bad. So I want this in the middle, this whole thing in the middle I should say. I want that whole thing to just be 1a. So I don't want any numbers here, so we'll subtract the 4. Okay, because our answer is supposed to just have a variable like these over here, like the b1 or that one or the n1. We just have a single variable. So we'll get rid of this. So we have 6a, negative 6 minus 4 is minus 10. And then we have 8a still in the middle, and then those go away. We're left with a. Okay, again, I just want a in the middle. I don't want 8a in the middle. So what can we do here? Well, let's take away the number, the a's that we don't want here. So we have 8a, so we can take away basically 7 of them if we wanted to. If we subtract 7a, there's a couple ways you could do this problem, but we'll we'll do it this way. So 6a minus 7a would be negative a minus 10 is less than or equal to a, and a minus 7a is less than or equal to negative 6a. Alright, so again, that's still kind of confusing because we would like it to be a greater than a number and less than a number. Right now we still have these a's in it. So here's what we can do. We can basically separate this off into this section right here. We can solve this individually, and then we can do this section right here and solve that individually. And this will make it easier for us. So let's start with the left side. We want to get all the a's on one side like we did before, so we'll add a to both sides. So we have negative 10 is less than a plus a is 2a, and let's divide by 2. Again, we don't have to flip the sign because we're dividing by positive 2, even though that's a negative. That's not what we're doing. So a is greater than, and then negative 10 divided by 2 is negative 5. So that's our first half of our equation. Over here, let's move all the a's to one side. So a plus 6a would be 7a, and on the other side we have 0. So if we divide by 7, we would get a is less than 0. So now let's try to graph this, and we'll see why this is called an AND statement. Okay, so remember these because I'm going to have to move it. It says a is less than 0 and a is greater than negative 5. So notice, first of all, we're not going to shade in this line right here. So at negative 5, I'm going to draw the dot here, but it's going to be unshaded in because a is only what does it say? Greater than negative 5. So where our number is greater than negative 5, going this way. I'm not going to go further than that though because I want to see what's going to happen with this other half. So the other half says a is less than 0, not less than or equal to, just less than. So we're going to keep this open, and then less than 0 is here. And maybe you can see why from the picture why this is called an AND problem, because not only is a is basically both of these at the same time. It is possible for a to be both greater than negative 5 and less than 0 at the same time, and that's what the picture looks like. That's what the graph looks like on that inequality.